Today we're going to learn about relations and functions, and we're going to learn how to graph relations and identify a function. So let's first identify what a relation is. A relation is a set of pairs of input and output values, and it can be represented as ordered pairs, a mapping diagram, a table, or even a graph. And ordered pairs meaning that you have a x and y coordinates, and of course the x is the input and the y values, those are your output. Or you can do a mapping. A mapping has arrows that show how each input is paired with each output. So this one would be input. I'll put I for input, O for output. Or you can have a table of values where X is still input and Y is your output. Or on a graph, you can also show the input output by the points on the graph. So those are the four ways that relations can be expressed. Now, of course, in each of these relations, we have what are called the domain and range. And just like we have X and Y, input and output, the domain, those are your X coordinates. The range, those are your Y coordinates. So input would be your domain, or the set of inputs, the X coordinates, those are your domain. The set of outputs, Y coordinates, those are your range, or your range values. So for example, you're going to see these brackets that represent a set. Let's say we had -3, 14, 0, 7, 2, 0, 9, -18, and 23, -99. And let's say they wanted us to find the domain and range. And when you write it, you use those little brackets to actually identify the domain. And it really doesn't matter which order you put it in. Some books do smallest to largest, some do largest to smallest. It doesn't matter. So domain, we're looking at all the X coordinates. So we have -3, 0, 2, 9, and 23. And if you see a number being repeated, you don't have to write it twice. And then the range, those are your Y coordinates, and I'm doing those in pink. So we have 14, 7, 0, -18, and -99. And the good thing about this is alphabetical order. D comes before R, X comes before Y. So, and even in input comes before output, I before O. Now, a function is a special type of relation in which each element of the domain corresponds with exactly one element of the range. That means that each x, or input value, has its own y. Oh, own y. So that means that it can't share with any other ordered pair. So for example, if we had this mapping, here's our domain, here's our range. Let's say we had -3, 0, and 4, and -2, 1, and 7. So the -3 is with the -2, the 0 is with the 7, the 4 is with the 1. If you notice, each arrow going from the domain to range corresponds with exactly one y. So this would be a function. And if you're ever unsure, you can always write them out as ordered pairs so you can check. And then here's another one. Here's domain, here's range. And we have 2, 3, 4, 6, -3, -1, 3, and 6. Let's say that 2 was going to -3, 3, 3 was going to -1, 4 to 3, and 6 to 6. Now, if you notice, the 2, which is in the domain, which is the x, is being paired with -3 and 3. And because of that, this is not a function. So anytime that happens, you have to look, because they can give it to you as a mapping or a set of ordered pairs. Your job is to find out if there is a x that is being shared with more than one y coordinate. It's okay for the y coordinates to share the same x, but the x's can't share. The same x can't go to two different output values. And as ordered pairs, you look at the x coordinates and you check to see if there is one being repeated. So like in this particular example, if you notice, I have a 4 going to a -1 and a 4 going to a +1. This is not a function. The vertical line test can also be used to tell whether a relation is a function, and we usually do this on graphs because sometimes we can't see the points, the order pairs, or the mapping, and it's hard to actually just look at it and tell. So let's say we had this graph. And what you would do is take a vertical line, sometimes we use our pencils, and you would roll it across it vertically. And if there is a case where this vertical line passes through your graph more than once, then it fails the vertical line test. So in this one, that means that there is a x coordinate that is being paired with two different y coordinates. So this will be not a function. And then you have this example. Of E. And if you use your vertical line test and you roll it all the way across from one end to the other, you will notice that it will not hit the vertical line, or the graph won't hit the vertical line more than once. So this one is a function. You just have to make sure that you're rolling your pencil or your pen, making sure that it's rolling vertically. Function notation. Functions and equations are similar, but a function also has an input and an output. And it's like a function rule. So y equals 3x plus 2 would be the equation, where x would be input, y would be output. And then if I had f of x equals 3x plus 2, and it's read as f of x, or function f of x. This represents the x, or the independent variable, represents the input. So here, this would be where you would input. And this whole thing, the f of x, that would be your output. And then this x value is also right there. Now this x in the equation, that's your input, and the y is your output. So if you notice, they are similar, where x is the independent variable, f of x, or your y, is the dependent variable. And so they will give you values to plug in. And let's say they wanted us to plug in -1, 0, and 3 into our function. So for the first one, you will write it as f of -1. Because it's saying -1 is your input. So in your equation, or your function, you're going to plug in -1 for x. And then part B, your input is 0. And for part C, your input is 3. So in the first example, you get -3 plus 2, which is -1. So that means that your input is -1, your output is -1. So the actual answer represents your output. The second one, we'll get 2. So your input is 0, output is 2. And the last one, we will get 11. So your input is 3, your output is 11.